Alright class, today I'm going to try and teach you ellipses on the iPad. An ellipse, similar to a circle, but an ellipse is, typically an ellipse has a longer direction one way than the other, so in this case we're longer this way and shorter this way. If they were the same size, well then an ellipse can turn to a circle pretty quick. Okay, there's actually on page 742, there's actually a pretty good drawing of how you could, or pretty good demonstration of how you could draw an ellipse. If I put a pin down here and a pin down here, and I had a length of string that I tied one end to here, tied one end to here, and then I hooked the other end to a pen, and these would be straight, and then I went around this, you'd be able to see how this string would, a different color here, this string would be longer here, shorter here, but if I added this distance with this distance and this distance with this distance, let's name this something else, A plus B would equal X plus Y no matter where we are on this ellipse. So that's kind of how to draw an ellipse. We won't really do that in this class, but if you ever want to draw an ellipse, you just put two pins down, get a length of string, and trace around it. Alright. So now here we are. Back to the notes. Okay. If I have an ellipse, the center, we're going to call that the center. This point here and this point here, in this case, are vertices. Okay. I'll call it a vertex. Call this a vertex. They are our two vertices. The distance between two vertices is called the major axis. The other distance is the minor axis. There's some points here also, but we don't name those points. The two on the end are vertices. These two on top and bottom in this case aren't named anything. This is if we're oriented left and right. If we're oriented up and down, again, this is still going to be the center, but now our vertices are here and here. Our major axis now goes up and down. And our minor axis in this case goes horizontally. Okay. What are some equations we're going to use? The standard form of the equation, if we're oriented left and right, or horizontally, like we are right here, is going to be x minus h squared plus y minus k squared equal to 1. Under here is a squared. Under here is b squared. Okay, if we're oriented up and down, our equation is, and these are in the book, our equation is going to be x minus h squared over b squared plus y minus k squared over a squared equal to 1. So there's some subtle differences. You'll notice that the a's and b's switch spots. Actually, that's about it. You might notice some similarities between parabolas. The h is still going with the x. The y and the k are still together. Okay. For both of these, that's the case. All right. The center for both of these is going to be at h, k. The vertices, for those that like notes, put the vertices in here. Maybe let's talk about A first. A is this distance right here, from here to here. From your center, A is the distance from center to vertex. Okay, in both directions, so positive, negative. A is the distance from your center to your vertex. And that's here, from my center to my vertex, this is A. Okay, this distance from here to here. Up here, it's from here to here. This distance is A. The other distance is B. So B is the distance from your center to the end of your minor axis. Down here, it's from here to here. This distance is B. Okay? So, my vertice, if, for those of you that like to use formulas, my vertices, if I'm oriented horizontally like this, are going to be H plus or minus A, K. So this point right here would be H plus A to get to here, and then K would be my my vertical height. The other vertice would be H minus A, right? So there's where your plus or minus A come in. My vertices down here, so the center is the same. Center is still HK, but this time my vertices, I spelled vertices wrong up here, didn't I? There you go, for those of you that don't like that. Okay, so vertices, this time it's going to be H, but my K is going to be plus or minus A. So let's look at why that's how it is. If this point right here is HK, to get to this point, I'm going to go up from my Y value, my K value, A. And then to get down to here, I'm going to go minus A. Alright? So that's how to get the vertices. The last thing I want to talk about, there's a relationship between A and B. And it turns out that A squared minus B squared equals C squared. Now, what do you think C is? C is the distance from your center to your focus. So from my center here, okay, and it's right here. Not up there. From my center to my focus, we'll put the focus right here. This distance is C. Okay, same thing in this direction would be negative C. So I've got vertices here. You know what? I'm going to wipe this slate clean. I'm going to make my notes a little better here. Okay, when we're oriented this way, center HK. Vertices H plus or minus A, K. Focus H plus or minus C, K. So here's my center, HK. Focus would be right here. Vertice right here. Focus right here. Vertice right here. Okay? If I'm oriented up and down, center, again it's still HK. Vertices, we'll do vertices first. Vertices are HK plus or minus A. Focus is HK plus or minus C. So here would be my center, focus plus or minus C, vertice, vertice. Alright, and then the relationship that ties it all together is A squared minus B squared equals C squared. A little bit long. Let's do some problems. We'll go ahead and do example 1 next.